Whenever any two real functions are given, add them in such a way that f of x plus g of x for all the values of x belongs to x. Whenever you have any two real function f from x to r and g from x to r, then we define f minus g from x to r by f of x minus g of x. You can divide any two function in the form of f of x by g of x, but the condition is the denominator cannot be equal to 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the algebra of functions and the domain and range of some real functions. We have already learned few examples of finding domain and range of real function, and in the previous session we have learned some standard functions, domain, range and graph of their function. And in this session we are going to learn algebra of function along with its domain and range. Let's see algebra of real function. Let me take two real functions f of x and g of x. Then the addition of two real function in the domain set of real numbers to real numbers is given by f plus g, where x to r, where x is a subset of r, x is a domain which is a subset of r, and it is defined by f plus g of x is equal to f of x plus g of x. So whenever any two real functions are given, add them in such a way that f of x plus g of x for all the values of x belongs to x. In the subtraction of real numbers, whenever you have any two real function f from x to r and g from x to r, then we define f minus g from x to r by f of x minus g of x. Multiplication by scalar. Any scalar quantity can be multiplied to any function f of x or g of x. So if I have taken alpha as a scalar quantity, then alpha can be multiplied to a function. Suppose if you have x square, then 3 is any scalar, then you can write it in the form of 3x square. Next, multiplication of two real function. Multiplication of two real function is the product of two functions. So therefore it is given by f of x into g of x. Next is the quotient of two real function, that is the division of any two real function. So you can divide any two function in the form of f of x by g of x, but the condition is the denominator cannot be equal to 0, or the function which is in the denominator cannot be equal to 0, that is g of x cannot be equal to 0. So this is how the operations on real functions are defined. So let us try these operations on few examples of real function. The first one is f of x is equal to x, g of x is equal to root x be two function defined over the set of non-negative real numbers. Find f plus g of x, f minus g of x, f g of x, f over g of x. So f plus g of x is nothing but f of x plus g of x, that is x plus root x. F minus g of x is nothing but f of x minus g of x, x minus root x. Next, f g of x is given by x into root x, or you can write it as x to the power 3 by 2. Next, f by g of x is given by f of x by g of x. So here x over root x you will get, so which can be written as root x. So this is the value. Next, let f of x is equal to x square, g of x is equal to 2x plus 1 be two real function. Find f plus g of x, f minus g of x, f g of x and f over g of x. So let us find f plus g of x. The sum of two real function, that is x square plus 2x plus 1. Next we have the difference of two real function, that is x square. Since 2x plus 1 is a binomial, use brackets. So you will get the answer x square minus 2x minus 1. Next we have f g of x, so which is nothing but product of two real function. So you will get 2x cube plus x square. Next we have f over g of x. So that is in the form of x square by 2x plus 1. The condition is here, the denominator cannot be equal to 0. That is 2x plus 1 cannot be equal to 0. That means x cannot take the value 1 by 2. So the condition here is x cannot take the value 1 by 2. Minus 1 by 2 here. So we have plus 1, so it is minus 1 by 2. X cannot take the value minus 1 by 2 because it becomes 0. So this is how we will define the operations on two real functions. Next we have, let f is a function whose ordered pairs are given 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Be a linear function from z into z, find f of x. We have studied what do you mean by a linear function. Any function in the form of y is equal to mx plus c. Or we can take y is equal to ax plus b, any two constant. Any function in the form of this can be taken as a linear function, and here we have defined the linear function from the set of integers to set of integers. We need to find or we need to define f of x here. The values are given. We know that if a comma b belongs to any function, then we can write f of a is equal to b. So similarly here 1, 1 belongs to f means that is 1, 1 belongs to small f can be written as f of 1 is equal to 1. And we have 2, 3 here. So 2, 3 belongs to f. This implies f of 2 is equal to 3. So therefore, all the other function can be written in this form. F of 0 is equal to minus 1. F of minus 1 is equal to minus 3. And we know it clearly that it's a linear function. Linear function should be in the form of mx plus c. So therefore, this can be written in the form of f of 1 means. So here in the place of x, just substitute x as 1. Then you will get m plus c is equal to 1. Here you can see in the place of x, if you substitute 2, you will get 2m plus c is equal to 3. And here you can see m into 0. So 0 plus c is equal to minus 1. And the last one you can see minus m plus c is equal to minus 3. So using the equations here, you can clearly see the value of c is equal to minus 1. Now taking the first equation, m plus c is equal to minus 1 or plus 1, m plus c is equal to 1. The value of c is minus 1. So m minus 1 is equal to 1 implies the value of m is equal to 2. So what is the function name? Then my function is, therefore it is y is equal to, what is the value of m and c there? M is 2, c is 1. So therefore it is in the form of 2x minus 1, or I can write f of x is equal to 2x minus 1. So this is how the given function is defined. Next we have here set A contains 4 elements 1, 2, 3, 4. Set B 1, 5, 9, 11, 15, 16, and f is given 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Are the following true? F is a relation from A to B. F is a function from A to B. Justify your answer in each case. You can see if you write A cross B, that is how many elements are there in A cross B. Here n of A is 4 and n of B is 6. So therefore A cross B contains 24 elements. That is in the form of a ordered pair A comma B, that is 1, 1, 1, 5, 1, 9, 1, 11, 1, 15, 1, 16. So 1, 5 is among them, 2, 9 is among them, 3, 1 is among them, 4, 5 is among them, and 2, 11 is also among them. Hence, clearly you can see here F is a subset of A cross B. So whenever this set is subset of A cross B, we can clearly justify that F is a relation from A to B. Now, they are asking one more question. Is it F is a function from A to B? Clearly, you can see here, two ordered pair contains the same first element, or we can say 2 has 2 images. that is 9 and 11. To define a function in a set, we should know that every element should have only one image in the codomain. But here element 2 has two images. So therefore clearly we can say f is not a function from a to b. It is just a relation from a to b. Next, let f be the subset of z cross z defined by f is equal to a comma b comma a plus b. A, B belongs to Z. Is f a function from Z to Z? Justify your answer. So here clearly f can be a subset of Z cross Z. That is, it can be a relation in the Cartesian product Z cross Z. But let me take any two elements because A comma B belongs to Z. Let me take the elements minus 2, minus 3 belongs to Z. Then we can clearly say that AB, that is minus 2 into minus 3, which is 6, and A plus B, minus 2 plus minus 3 becomes minus 1. So this belongs to F. So 6 comma minus 1 belongs to F. Let me take two more elements, 2 and 3 belongs to Z. Now according to the relation AB comma A plus B, A into B, 2 3s are 6 we have, and A plus B means 2 plus 3, 5 we have. So 6 comma 5 also belongs to the given set, that is F. Now see here, 6 has minus 1 has the image, 6 has 5 as the image. According to the definition of a function, every element should have only one image, but here 6 have two images. So therefore, the given set F is not a function from Z to Z. It is only a relation which is a subset of Z cross Z. Next, find the domain of real function x square plus 3x plus 5 divided by x square minus 5x plus 4. So whenever a rational function is given, we should know that the denominator polynomial cannot be equal to 0. So therefore here clearly x square minus 5x plus 4 can be factorized in the form of x square minus 4x minus x plus 4, which can be written as x minus 4 minus 1 x minus 4. So x minus 4 and x minus 1 are the roots of this quadratic equation. So what do you mean by the roots of quadratic equation? That means x is equal to 4 and x is equal to 1 are the solutions of this equation, which makes the equation 0. So therefore, the function here given, the denominator value cannot be equal to 0. So therefore, the domain can be any real number except 4 and 1. Because for 4 and 1, the denominator becomes 0. So therefore, the domain of the given function is all the real number except 1 and 4. So next question is, find the domain and range of the real function f of x is equal to root of x minus 1. So when I say a square root of a function, we should know that the value under the square root is always a positive. So therefore, here we have root of x minus 1. So to make it positive, x can take the minimum value of 1. So that means if x is equal to 1, it is square root of 0. So clearly, we should know that here x minus 1 is greater than 0. So this implies greater than or equal to 0. That means a positive. So therefore, x value is greater than or equal to 1. So therefore, the domain of this function is from 1 comma infinity. It can be any positive real number greater than or equal to 1. Coming to the range here, we know that x minus 1 is greater than or equal to 0. Taking square root on both sides. So that means what is square root of 0? It is 0. So x minus 1 is greater than or equal to 0. What is root of x minus 1? Our f of x. So this implies f of x is greater than or equal to 0. That is, image of x is greater than or equal to 0. So therefore, my range is from 0 comma infinity. So non-negative real number. So the domain is from 1 comma infinity, whereas the range of the given function is 0 comma infinity. Next, let x comma x square by 1 plus x square where x belongs to R be a function from R to R, determine the range of the function. So clearly, let me take y is equal to some x square by 1 plus x square. Now we can clearly see x square by 1 plus x square here. It's a positive quantity. So therefore, my x is a positive set of real number, or clearly we can say x belongs to R, a set of real number. My domain is a set of real number. I need to find out the range. So solving it here, we will get x square is equal to y divided by 1 minus y here. So solving this, or we can write x is equal to plus or minus square root of y divided by 1 minus 1. Now again it is a square root function. We know that square root function, the value under the square root must be always positive. That is, y by 1 minus y is greater than or equal to 0. Also, one more condition we have here, y cannot be equal to 1, because when y becomes 1 here, the denominator becomes 0. Therefore, one more condition here is y cannot take the value 1. Therefore, clearly you see here, this implies y is greater than or equal to 0 and y cannot take the value 1. So, therefore, range of this function lies between 0, 1. Next we have, let A is equal to 9, 10, 11, 12, 13 and let F is a function from set A to the set of natural number defined by f of n is equal to highest prime factor of n. Find the range of F. So we are defining set A to the set of natural number. So we have set A here. Set A contains 9, 10, 11, 12, 13. And we have a set of natural numbers 1, 2, 3, 4, etc. until infinite. So we are defining a function from set A to natural number. So what does our function says here? So that is the highest prime factor of n. Now let me take f of 9. So what are the prime factors of 9? The prime factors of 9 are, so the prime factors of 9 are 3 only. Therefore, the highest prime factor of 9 is 3. So next, what are the prime factors of 10? We have 2 and 5. But what are the highest prime factor? So therefore, the highest prime factor of 10 is 5. Next, what are the prime factors of 11? It is only 11. So therefore, f of 11 is 11. Next, what is the highest prime factor of 12? So we have 2, we have 3. So therefore, the highest prime factor of 12 is only 3. Next, we have 13, which is a prime number again. So therefore, highest prime factor of 13 is 13 itself. So you can clearly see here, if I write this in the form of a set, you can pair it. That is, we can write it 9, 3, next 10, 5, next 11, 11, next 12, 3, next we have 13, 13. So all the element in set A have only one image in set N. So and the range of this function, range of f is clearly 3, 5, 11 and 13. This is a function and range of the function is 3, 5, 11 and 13. So thus we have studied how to find the domain and the range of certain functions under the given conditions. So this is all about the chapter relations and function. We will meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.